Hello everyone, welcome to Karnataka LMS. I am Latarani HM, Assistant Professor of Mathematics, Government First Grade College, Kernagra. In this video, we learn about limit of a complex function. In the previous classes, we learnt about definition and basic concept of the complex number and also equation of a straight line and circle of a complex function. Now we discuss about function of a complex variable. Definition: let D be a set of complex number and Z and W be a two complex variables. Then the complex variable W is said to be a function of the complex variable Z. If to every value of Z in the domain D there correspond one or more values of W. This can be denoted by W is equal to f of Z. Means ಇಲ್ಲಿ ಎರಡು ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ ಇದೆ, ಒಂದು Z ಮತ್ತು ಇನ್ನೊಂದು W. ಈ ಎರಡು ಕಾಂಪ್ಲೆಕ್ಸ್ ವೇರಿಯೇಬಲ್ ಅನ್ನ ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ವೇರಿಯೇಬಲ್ ಕ್ಯಾನ್ ಬಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಇನ್ ಫಂಕ್ಷನ್ ಆಫ್ ಎ ಅನದರ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ವೇರಿಯೇಬಲ್. ನಾವಿಲ್ಲಿ W ಅನ್ನ ಫಂಕ್ಷನ್ ಆಫ್ Z ಆಗಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. Therefore, we take W is equal to U plus IV and Z is equal to X plus IY. ಹಾಗಾಗಿ ನಾವೇನು ಮಾಡ್ತೀವಿ, W is equal to f of Z ಅಂದರೆ f of Z is nothing but function of a X plus IY. ಹಾಗಾಗಿ what is W? W is a U plus IY, I into V. Therefore, U plus IV is equal to f of Z. That means U and V are a function of X and Y. ಈ ಡೆಫಿನೇಷನ್ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಮುಖಾಂತರ ನಾವು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡೋಣ. ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ f of Z is equal to e power Z. We can put Z is equal to x plus iy. Therefore, e to the power of x plus iy. Now, e to the power of x plus iy can be written as e to the power of x into e to the power of iy. Here, we are used the Euler's formula. E to the power of iy can be written as cos y plus I sin y. Now, multiply e power x, then we get e power x into cos y plus I into e power x into sin y. But f of Z is nothing but u plus iv. Therefore, we are equating the real part and imaginary part in both LHS and also RHS. Therefore, u is equal to e power x into cos y and v is equal to e power x into sin y. One more problem. F of Z is equal to sin Z. Again put Z is equal to x plus iy, and here we are using the compound angle formula, sin of a plus b formula. Sin a cos b plus cos a sin b. Here we cannot separate u function means real function and imaginary part. Therefore, we are substituting the value of cos iy. Cos iy can be written as, in the previous class we know that cos I into y can be written as cos hyperbolic y and sin iy can be written as I into sin hyperbolic y. Now we can easily write u value is a real part and v is equal to cos x into sin hy. These are the some more problems. Now we move on to the limit of a complex function. Definition: a function W is equal to f of Z is said to tend to a limit L as Z tends to Z naught. If for all epsilon greater than 0, there exists delta greater than 0 such that mod f of Z minus L less than epsilon for all mod Z minus Z naught less than delta. Here epsilon and delta are a very small number. We can write this is the statement or definition of the limit of a function, but this can be written as limit Z tends to Z naught f of Z is equal to L. Here L is a limiting function. This limiting function should be a finite and unique. Now we discuss about some problems. Consider one example, one problem, that is evaluate limit Z tends to 1 minus I Z square minus 2Z plus 1. Consider the limiting function limit Z tends to 1 minus I, z square minus 2z plus 1. Here z approaches to 1 minus I. Therefore, we can substitute z is equal to 1 minus I. That is 1 minus I whole square minus 2 into z value is 1 minus I plus 1. Now simplify this one. Here a minus b whole square, that is 1 square plus I square minus 2i. Minus 2 into minus I is plus 2i plus 1. After simplification we get minus 1 value. This is the limiting value of the given limiting function. Now we move on to the next problem. Evaluate limit z tends to I, z cube plus I whole divided by 1 minus zi. Consider the limiting function z tends to I, z cube plus I divided by 1 minus zi. Now here z approaches I value, therefore we can substitute z is equal to I. That is I cube plus I 1 minus I into I. That is I cube can be written as minus I, because I cube can be taken as I square into I. I square value is a minus 1. Minus 1 into I can be written as minus I plus I divided by 2. That is limiting function is 0. Now we move on to the third problem. Here show that limit z tends to 0, z bar by z does not exist. In this problem we can show that limit does not exist. Solution. Let us consider limit z tends to 0, z bar by z. Here we cannot put z is equal to 0 because here we have z bar and in the denominator we have z. Z bar represent a conjugate. Therefore, limit x minus iy, it is a conjugate of z divided by z value is x plus iy. Means this z can be expressed in terms of x and y. Therefore, z approaches to 0. That means z is nothing but x plus iy approaches to 0. That shows x and y variables approaches to 0. Here we see two cases. One is x tends to 0, another one is y tends to 0. This one is solved by using two cases. First case is along x-axis. Along x-axis means in the x-axis y value should be 0. Therefore, put y is equal to 0 in the limiting function and x tends to 0. Z tends to 0 means x tends to 0 and y in x-axis y is 0. Put y is equal to 0. X minus 0 divided by x plus 0. Here x get cancelled. Function is 1. Therefore, limit x tends to 0 of 1 is 1. Then consider the another case, that is along y-axis. In y-axis, x value should be 0. Therefore, put x is equal to 0 in this function. Then limit y tends to 0. Here x will be 0. Then we get minus iy divided by plus iy. Here iy get cancelled. Remaining is minus 1. So here in the two cases, first case limiting value is a 1. In the another case limiting value is minus 1. This contradicts the definition because the limiting function should be a finite and also a unique. But here we have the different answer. Therefore, does not exist. Consider another example. Limit z tends to I, z square plus 1 divided by z to the power of 6 plus 1. Nodi, ಇಲ್ಲಿ z approaches to I. Z approaches to I means we can put z is equal to I. ನಾವು ಇಲ್ಲಿ z is equal to I ಆಗ್ತಾಗ ನಮ್ಗೆ ಏನು ಬರುತ್ತೆ ಅಂದರೆ I square is minus 1. Minus 1 plus 1 is 0. Here I to the power of 6 means I square into I square into I square. I square into I square into I square. Again we get minus 1. Minus 1 plus 1 is again 0. Here we take 0 by 0 form. This function takes 0 by 0 form when z approaches to I. Therefore, 0 by 0 form ಇರೋದ್ರಿಂದ here we can use two method. One is formula method, ಇನ್ನೊಂದು ಯಾವುದಿದೆ L'Hospital rule method ಕೂಡ ಅಪ್ಲೈ ಮಾಡಬಹುದು. Here I use the formula method. See here, z square plus 1 z to the power of 6 plus 1 can be written as z to the power of 6 plus 1 can be written as z square to the power of 3 plus 1 cube means a cube plus b cube formula. Here we are apply the a cube plus b cube formula for the denominator. What is the formula of a cube plus b cube? A plus b into a square minus ab plus b square. See, a square plus b into a plus b into a square plus b square minus ab. Now z square plus 1 and z square plus 1 is get cancelled. Remaining is 1 divided by z to the power of 4 minus z square plus 1. Now put z is equal to I. 1 divided by z to the power of 4 means minus 1 into minus 1, that is plus 1. Again minus into minus 1, that is plus 1. We get 1 by 3. Here I already told, if you get 0 by 0 form or infinity by infinity form, then we are using the L'Hospital rule. What is L'Hospital rule? L'Hospital rule means it is nothing but differentiate numerator and denominator separately with respect to z. What is the differentiation of z square plus 1? Differentiation of z square plus 1 is nothing but 2z. Then differentiate denominator with respect to z. Means here we are applying the differentiation for numerator and denominator separately. That's why differentiation of numerator is 2z. Differentiation of denominator is 6z to the power of 5. So 2z divided by 6z to the power of 5. So 2 by 6 is 1 by 3. 2 by 6 is 1 by 3. Then z by z to the power of 5 means 1 by z to the power of 4. 1 by z to the power of 4. Now approach z tends to I. Z tends to I means we can put z is equal to I. 1 by I to the power of 4. 1 by I to the power of 4 means what? That is minus 1 into minus 1 plus 1. Again we get the same limiting function. So this problem is solved by using two methods. One is formula method. This is the formula method, and one more method is there, that is L'Hospital rule. L'Hospital rule means differentiate numerator and denominator separately. This is the one more problem. Limit z tends to e to the power of I pi by 4 z square divided by z to the 4 plus z square plus 1. Here we can put z is equal to e to the power of I pi by 4. We can solve this problem also. Thank you.